My research, I have a website in case you don't want to listen to me and you want to look at some pictures in more detail or videos, underwatermaya.com. And I'm going to see if this works to click on it. Can you click on that go sign at the bottom? This will take you to our website, maybe? Might as well find out right at the front. Okay, so here's the DIVA Lab website, and if you scroll down on the left side there, you'll see lots of things. So you can just cut that. So anytime you want to check anything, you want more details while I'm talking, just get out your cell phone, get out your laptop, and we even have a 3D head scan of President Alexander on the website. It was approved by him. And we have a 3D printed replica of Dean Haney, who is here, in the exhibit outside the DIVA Lab in Howe Russell, if you want to see her. Well, she's in person, but if you don't want to talk to her, you just want to talk to a 3D printed replica, that's fine. So if you could close this out, please. Okay, so I want to talk about salt. I'm going to talk a little bit about my research. I'm not going to do any math or anything. Archaeologists do statistics and things, but we're not going to talk about that today. I want to talk about salt. And some of you may be on a salt-reduced diet. And if a medical, okay, I'm a doctor, but I'm going to tell you salt is good. But if a medical doctor told you to reduce the amount of salt, listen to them. But generally, in a healthy individual, your kidneys regulate the amount of salt. If you have too much salt, they excrete it. If you don't have enough salt, the kidneys will hoard it, so you have enough. Salt is a basic component of the intercellular system of the human body. You need salt, and I don't have to tell an audience in Louisiana about salt. Salt is also one of the 4 taste sensations on the tongue. It is a flavor enhancer, and it certainly is an important ingredient in the cuisine of Louisiana. So why do I say salt is so important? I have seen on my archaeological projects, and some people can vouch for this, that not enough salt, you get kind of achy joints. And if you're involved in sports, you may have experienced this. Achy joints, kind of weak and delirious a little bit. It gets worse from then on, but I'm not going to talk about that. But I've found if you just put a little salt in the Kool-Aid, it perks them right up, just like pouring water on flowers. So salt is very important. And one of the things that I've found is that the great ancient Maya civilization, now I don't work here, I have been here, I took this picture at the top of one of the temples, Temple 1 at Tikal, but the Maya, the classic Maya of Central America, had great cities of over 100,000 people in the rainforest, but they didn't have salt, and so they needed to get salt. Some of their cities were over 100,000 people. So where did they get the salt? How did they organize the distribution patterns to make sure that they got enough salt every day so they wouldn't get achy, weak joints and feel delirious and ultimately die? So that's what my research is about. It was scarce on the coast. So where do people get salt? In general, if you're a hunting and gathering society, so let's go way back in time or go to faraway places like the Kalahari Desert in Africa or the Australian Aborigines, hunting people generally get enough salt from eating meat in their diet. But once you get farming populations, and certainly ancient civilizations are founded on carbohydrates, corn, rice, potatoes, millet, barley, in the various places in the world. And those are deficient in salt, so they need to find some extra salt. You can get rock salt, that's under Detroit. In the Maya area, you can get, it came up, the Yucatan Peninsula. You can see an insert map here which shows Mexico and Belize, which is where my research in the larger map is in the southeast corner of Belize, and then it's adjacent to Guatemala and Honduras. But on the north coast of the Yucatan of Mexico, it's really hot and dry. It's arid. In fact, there's droughts up there, and they have solar evaporation of salt. But once you get farther south into the rainforest, it rains a lot, and you can't do that solar evaporation. And so they use a technique, which you see pictured here from an artist's reconstruction, of evaporating brine in pots over fires to make salt. This is very common around the world, from China to Thailand to Africa to England, in modern times, right here in Louisiana, in fact. And so this was a way that they produced salt. This is Paynes Creek National Park. It's an underused park. This is a typical day in the park. No one's there. Our whole research area is devoid of people during the day. There's a little bit of import-export activity at night, but we generally work in the day, and so we don't communicate with them. They know we're there, though, of course. So I had written a book on 3 sites that we found underwater. Salt, white gold of the ancient Maya. But I thought, 3 sites, that doesn't really make an impact on the amount of salt that would have been needed. So I thought, we need to go and systematically search the lagoon to see if there are more sites. So I got a faculty research grant from the Office of Research and Economic Development at LSU, which allowed me to hire someone with a fast boat. And you see my boat driver there, more than a boat driver. He jumps in the water, and look at that big piece of pottery he's got. That's because the sites are underwater, and there's no one trampling on the sites and breaking up the pottery. It's on the seafloor, embedded in the seafloor. So we were systematically walking back and forth, looking for more sites and finding them. It's kind of difficult. We're in the Caribbean. We've got rubber boots and bathing suits and hats, and every step is like the Stairmaster. But we did find sites, and we recorded them. Then we found an unexpected discovery right there. We found a peat bog in the eastern arm of the lagoon. Now, some of you may know about peat bogs in Europe, where they find bodies preserved for 5,000 years, perfectly preserved, the skin, the hair, the eyelashes, the fingernails. Well, we weren't going to find that because it's a different kind of peat, and also the temperature difference, and the chemistry is a bit different. But we found a peat bog created by mangroves, red mangroves, you know, the ones that grow in the water, in the salt water. And they are a proxy for sea level rise, because as sea level rises, they grow taller to keep their leaves above water, and they trap sediment and other leaves and things, and that provides the proxy record of actual sea level rise. So we study the peat, and we look at the relationship of the sites, which have obviously now been submerged by sea level rise. If the sea level rises too quickly, the plants can't grow fast enough, and they're flooded out and they die. And clearly that's what happened here eventually. But when we first started, we didn't know. So we didn't find bodies. What did we find? We found wooden buildings dated to the classic Maya. And you see here, I hope, no, didn't go. Let's see. Okay, you see here the photo of, that's my tired team. I'm taking the photo, someone has to do that. The first post we found, there's our group photo, and I'm big on taking photos of everything, like 2D photos, not just 3D. And so we radiocarbon dated them, and they date to the late classic. That's AD 600 to 900. And we found hundreds of them. We have individually mapped now, over 4,000. We have 110 underwater sites. It's a massive salt industry. It's really incredible. And it's LSU undergraduate and graduate students and me, and I've had other colleagues also working on the project. So the significance of this is, you saw that first picture that I showed you of Tikal with the stone temples. There's lots of Maya sites that have stone buildings in the center of the city. So that's what tourists see when they go to the Maya ruins. You see the temples, the palaces. But what you don't see are the hundreds and the thousands of houses and workshops and storage facilities that were made of pole and thatch, like this modern Maya village today in southern Belize. And you look here, and there is a stone church, but that's it. All the other things would have decayed, just like in Louisiana, where wood does not preserve normally. So we have the peat, which is very organic, and there's no oxygen to decay the wood. And you saw the picture, it looked pretty nice, except it's waterlogged and full of salt. So I realized that we had to stop walking through the mud and destroying the sites. I also realized when I asked my colleagues after I announced this at a conference, did they think I was going to be able to get any funding? And they said, oh yeah, you're going to get funding. And I did work hard, but we got funding, and also got National Science Foundation funding to have a multi-year project mapping ancient wooden architecture on the sea floor. And we started a new technique of systematic survey. Instead of pedestrian survey, we were traversing on research flotation devices, RFDs, back and forth systematically. And if you can click the right image, it's a movie that might come up on the bottom left corner of the right image. Yes. Okay, so here you can see, this is my first DVD. I'm standing in the water, imaging them, and it's like 10 minutes, 18 minutes per traverse, and they turn around systematically, mark things as they find them. And if you want to watch this movie, it's my all-time most popular movie, maybe because it's my only really good one, but I have a lot. And so you can see this movie, or a clip of it, is on our Underwater Maya website. And you can see it now if you don't want to hear me anymore. So then we take a total station and individually map each artifact or each post, and download the digital data at our jungle camp in the evening, and use GIS to display and analyze the material. And so here you can see on the top right outline the posts, locations. And then what we did is, this is Geomedia by Hexagon, Intergraph Hexagon, largest geospatial company in the world. And then we took Geomedia 3D and extruded those 2D posts, and because we measured them, we knew the size, extruded them into buildings, and then put thatch roofs on them. So if you press that's a video, press the bottom left of that, it's a fly-through augmented reality based on our actual finds using air photographs and in Geomedia 3D. So we're pretty happy about that. Let's see what happens. So then I got another grant with colleagues, Dr. Karen McKee, who's a mangrove ecologist, Dr. Harry Roberts, many of you know him, a marine geologist at LSU, and Dr. Terry Weinmiller, a former student, and we collaborated on interdisciplinary research, as well as a lot of LSU current and former students. And so we did excavations, and you note that excavation tool of choice. If you know anything about archaeology, forget it, but it's an 18-inch stainless steel kitchen knife. One of the most important things to remember when you're excavating with such an implement is where it is underwater. And if you are excavating with someone, you want to know where their big stainless steel knife is. But we're cutting the peat because it's solid. We also, Dr. McKee came down, and we did coring using a Russian peat core to reconstruct the vegetation history. And Harry Roberts had his tech design a automated research vessel, which came in parts, and we brought it down, put it together, programmed it from the computer, and it was going independently, as you see here, across the lagoon and getting sonar information of the sea floor. So that was pretty cool, and no one got to see it because this park is underused. A typical day, there's no one there except us. So no one has seen that from the local area. So what do we have? we have an infrastructure of production. It wasn't that kind of beach party that you saw at the beginning where people were wearing cute National Geographic outfits and making salt. No, it was an industry where people were making salt inside buildings where they could store firewood and the brine and the salt cakes. And this is based on a model from modern day salt making. This picture is from Sacapulas in Highland, Guatemala. And so this is the model that we're using. And on the bottom, you can see the briquetage, the broken bits of the pots. That's what we find by overwhelmingly 90 to 98% of the artifacts that we find abundantly in our excavations are this broken salt-making material. And we also found an infrastructure of transportation. At first, it sounds like, wow, one canoe paddle? Then you're going to call it an infrastructure of transportation? Well, people were pretty amazed because no one had ever found an ancient Maya wooden canoe paddle. And so it was made of sapodilla. It's 4'7". We exported it under temporary export permit, had it conserved at Texas A&M by a new polymer process. And before we returned it, we did 3D imaging of it. But we've since then found other canoe paddles, and we found a canoe. So I think you're getting towards an infrastructure of transportation as well. Anyway, no one else has this evidence. And it's made of sapodilla. I actually have exported under permit a big piece of sapodilla wood, that's the chewing gum wood, to make a 3D replica out of wood. So we have two big printers in the LSU DIVA Lab, but we also work with mechanical engineering, and we have done, with our same 3D files, we can run the CNC machines. So they take a piece of wood and carve it out. So it's an exact replica driven by our 3D model. So we'll be taking that over soon. I probably need to pay them, so I'm looking for some financial support for this idea. So eventually, there was rapid sea level rise, which drowned the mangroves and left the sites underwater until we came and recorded them and excavated and so forth. And what this has left us with is a conservation nightmare. The waterlogged wooden post, waterlogged pottery. You think pottery? Well, it's pottery. It's okay. Oh, no. The pottery dries, the salt comes to the surface and just cracks everything and exfoliates it. And the wood, it dries and cracks and it's gone. So anything we take out of the water that we want to keep to study or to 3D image, we have to keep in water. So anybody who's been to the Archaeology Lab, which I share with Dr. Chiquin over there, works in the coast of Peru, it's a Tupperware party with thousands of little plastic cheap containers with samples of wood and pottery. We desalinate them and have to keep them in water or they will decay. So, and you see those nice sharpened ends of the post. So I realized that the way to study things was to do 3D digital imaging. And so I applied for a grant from the Board of Regents in 2008 with colleagues in the Department of Geography and Anthropology to start the Digital Imaging and Visualization in Archaeology DIVA Lab. And I thought that name, DIVA Lab, was catchy, and they went for it. But I think we've done well by the name. And so here's Roberto. He's in 3D. If you want to click that little white print, you can see him in 3D and in 2D, scanning, doing a 3D image of the canoe paddle. And then, despite the conservation, the paddle continued to deteriorate. It was cracking. So we called over the conservators, and they were coming to Louisiana to see the people, the archaeologists at the state of Louisiana, and they stopped by and they said, it's just going to continue to deteriorate. You just have to put some glue in the cracks and fill it up. And at that point, I realized that our digital images were the record that was going to endure, because the actual artifact, despite the most sophisticated polymer conservation, which is really nice, that the artifacts are deteriorating. So we became very careful then with our research quality 3D imaging. And over on, if you can make that movie go, you can see a CT scan of the canoe paddle, and you can see all the cracks, and you can see the shaft has kind of a peel on it, like it's just exfoliating. It's just going to fall apart. And so I didn't tell that to the government of Belize when I returned the canoe paddle. I just said, it's fragile. Here's a kit to repair it. I did. So then we started scanning in Belize. We took our 3D scanners to the Belize, and here we are. You can see on the top left, there's one of my former students, Dr. Corey Sills, is now an assistant professor at University of Texas at Tyler. Here she is in the field, and she's found something, and she's holding in her hands a little boat model. And so we would typically, when we find things that are scan-worthy, we'll say, wow, that's scantastic. No, we don't say that, but got your attention. Anyway, yeah, I might say that on a bad day. So we put it in a bag of plastic bag full of water, take it back to our lab, and at night, in the jungle, under a house with no walls, infested with bugs, using a generator, we do science. We do a lot of other kinds of science there too, with the portable XRF and so forth. But we scan the things, and then we no longer take things back to LSU, or unless they're really important and have to be conserved. We cache them in deep silt in secret places in the lagoon with permission of the government of Belize. And so then we take our 3D models, our digital files, back to LSU, and then sometimes we print them. So here on the top left, you can see that little boat model. We printed it, and then we sometimes print them bigger so people can see them. And so we can vary what we do. And here you see on the top right, this is the Dimension Elite. It's a big 300-pound printer that does ABS plus plastic, really high quality. We can control it really well. And on the bottom, if you can make that movie go with that pretty pottery vessel, this is a photorealistic 3D color printer. This is a 3D scan, but I brought a print of that pot that was supported by the 3D printer, supported by the College of Humanities and Social Science. And we have wowed people at conferences and visitors who come to the lab, or I bring things here. So we're very excited. It also has weight. It's made of gypsum, so it weighs. Some of you have, I took some things around. I went up to strangers and said, they weren't really strangers because we're all here for the talk, but so I felt an affinity to them. I said, one of these is real. Now you can't see this, you can try the test later, but this one is real. I had to really think about it. This is heavy. These plastic things are really accurate, but behind a display case, they're really good, as long as you don't pick them up. Then you say, oh, they're plastic. They look great, but the gypsum has weight to it, and it also has texture, so you can feel the grains of the pottery. So it's very cool, and other universities, archaeologists don't have these printers. So everybody wants us to print things for them. They don't realize there is a learning curve, a steep learning curve to this process, and we spend a lot of time. My DIVA Lab scientists and I, undergraduates, masters, and PhD students. So here's an image that shows the dark brown one is the conserved original paddle. I wanted to take some photos before I returned the original to Belize, so I don't have the whole paddle, I just have the end, the blade, to compare them. See, the dark brown one has been discolored. It was not the original color of the wood. And then to its right, we have a 3D printed plastic replica, and then beside that one, painted. It looks pretty good. And then on the far right, we have a modern canoe paddle based on my drawing, what I thought it would have looked like had it been complete when we found it. And I got a woodworker friend of mine in Belize to carve it out of sapodilla. And then we put it in the water. And, well, we put a canoe in the water, and we used it to paddle, and it's perfect. And I can say that because I am I used to be don't look like a wilderness canoe guide, but I'm from Canada, if you haven't realized that. And I I know about canoeing, as most Canadians do, even those from Toronto, where I'm from. And then on the far left, you see one it's a piece of wood. This is cypress that I got from some friends in facility services who spend a lot of time in the DIVA Lab repairing the building. And so we do things. They gave me a piece of cypress, so we tried it out. Now we wanted the original wood. So we'll see how that works. And then we have also made 3D printed replicas of underwater Maya artifacts for exhibits. And we've done these in Belize with support from the Archaeological Institute of America, a site preservation grant, and we're going to be doing some more exhibits. We've done artifacts and then one featuring a full-size 3D printed replica of the canoe paddle. And we have hired someone to make display cases, and we have laminated information to go along with it, and we put them in public places so the people can see things. One interesting thing with this, we do strive for exact 3D replicas, and when we print, and people have told me they've seen the canoe paddle, and they're thinking the real canoe paddle, the one that no one sees. I gave it to the government of Belize, and it's in the museum somewhere. They haven't seen it. They've seen so I say, no, you saw the 3D printed replica. No, I saw the real one. When does the 3D printed replica actually become an artifact? If it's in use in a culture, can we just say that it's real? I mean, it is 3D and it is actually accurate. And I know that there are, the Smithsonian, for example, is making 3D printed replicas of headdresses that are used in dances by the Northwest Coast Indians, or First Nation people, I should say, in Canada. And because some of them were lost or they were broken, and they use them and they identify them as the real thing. So I think the edges are blurred between what is the real thing and what is a 3D printed replica. So it's interesting to us. And whoops, I should say, for display purposes, there's no commercial value on the international antiquities market. Maya artifacts from many countries in the world, have a high value on the illegal antiquities market. And so these don't have that. They also don't require permission from foreign governments. A small community like the place where we put these exhibits in Belize, they don't have to get permission. We can do it. I mean, I tell the government, they know what we're doing, but they're not interested in the fact that they're not real, so they don't care that we're putting them there. They think it's okay. And so this also makes things more accessible to the public and gets people involved, and they might protect our sites, which are just out there. And they do. They're very invested in them because they can take people out in small boats for fishing and bird watching and manatee and dolphin and snorkeling. And it adds value, puts money in the pocket of the small boat owners if they can also take them to an exhibit in Paynes Creek National Park and talk about the archaeology. So the 3D printed exhibits have great meaning to us to help protect our archaeological sites. So I have to thank a particular National Science Foundation. I've got another grant proposal pending, and don't laugh. Rachel wants to go back, right? That's right, we're counting on this. Along with Dr. Corey Sills, we've put this NSF proposal in to look for places where they may have lived, where were the salt makers living, were they doing other things. There were lots of activities that were related to salt production. And we have several big sites with multiple buildings and plazas that look more like Maya sites than just workshops along shorelines. So we have also got money, grant money from Archaeological Institute of America, National Geographic, and other sources, including LSU Office of Research for a faculty research grant, actually 2 of them. And humanities and social science, and a lot of blood, sweat, and tears from LSU students. So I will take some questions if anyone has questions. Thank you very much.